Welcome to a new Visual COBOL in a Nutshell video. This video will be an introduction to Rocket Visual COBOL for Eclipse. Over the next few minutes, I'll provide an overview of the Visual COBOL for Eclipse product, discuss concepts and background related to performing development tasks, and demonstrate compiling and debugging a simple COBOL program. In upcoming videos in this series, we'll explore the features shown in greater depth and cover the installation and configuration of the product. Finally, in this video, I'll be using Visual COBOL for Eclipse 11.0. If you are using a different version, some screens may appear differently. Visual COBOL for Eclipse is a state-of-the-art integrated development environment, or IDE, for COBOL development. It's built on the industry standard Eclipse platform. Visual COBOL for Eclipse is available on multiple platforms, including Windows, Red Hat, and SUSE Linux. Let's start by taking a brief look at the Eclipse user interface. We'll explore the product features shown in more detail later. This is just a way to introduce the various IDE components. Eclipse uses a familiar drop-down menu system, providing access to tools and features of the product. In addition to the menu, many options can be accessed with shortcut keys, which can be customized by the user. An example of this is using Ctrl+S to save changes to an edited file. In Eclipse, information is presented using three main kinds of screen components: editors, views, and toolbars. Editors are what you'd imagine, areas where program source or other files can be viewed and modified. Here is an example of an editor showing a simple COBOL program. Views are companions for editors and provide related information or navigation. For example, while viewing a COBOL editor, a companion view may show a navigable outline of the program. Views can appear by themselves or may be stacked in a tabbed notebook. The third IDE component in Eclipse is toolbars, which provide shortcuts to specific features relative to the tasks being performed in Eclipse. These Eclipse components can be arranged as desired to suit your needs. Toolbars can be resized, moved, or hidden. Views can be arranged as desired, stacked, minimized, and closed. Editors can be resized and repositioned. To get a larger, simplified interface while working, an editor or view can be maximized by double-clicking on its tab, temporarily hiding most of the surrounding views. Another double-click restores it. To help organize and present the user interface components for a particular task, Eclipse provides perspectives. A perspective is a collection of editors, views, and toolbars related to a particular kind of work. Visual COBOL for Eclipse comes with several different perspectives predefined. For example, there is a perspective provided for viewing and editing COBOL code, and another for using the debugger. You can access perspectives from the menu, or by clicking the Open Perspective button on the toolbar. Recently opened perspectives have buttons on the Eclipse toolbar, so that you can quickly switch between them. Now that we've taken a conceptual look at the basic user interface components of Visual COBOL for Eclipse, let's take a quick look at what you'll see the first time you start the product. When Visual COBOL for Eclipse is first started, a welcome screen is displayed. The welcome screen contains links and valuable information about the product, guides for first-time use, and more. After the welcome screen is closed, you can access it again later from the menu under Help Welcome. Next, let's take a look at the hierarchy used in Visual COBOL for Eclipse to organize your work products. In Eclipse, the highest unit of organization is a workspace. A workspace is a directory, typically on the developer's workstation or available network resource, and contains settings and configuration options related to your development experience. You can have multiple workspaces defined for use in Eclipse, but only one workspace can be open at a time. Each time you start Eclipse, the default behavior is to ask which workspace you wish to use. To create a new workspace in Eclipse, you choose File, Switch Workspace, Other, and enter the directory desired. Once a workspace has been selected, Eclipse loads the contents of the workspace. Or in this case, because I've specified a new workspace name, Eclipse creates a new workspace. COBOL development is best performed using a special Visual COBOL for Eclipse view named COBOL Explorer. Before I proceed, I'll make sure the COBOL perspective is active and the COBOL Explorer view is selected and visible. Now that the IDE is launched and a workspace has been specified, let's discuss the two different approaches available for working with COBOL programs in Eclipse. The first is standalone editing mode. This provides a quick way to view and edit a COBOL program. This is a nice intro for users new to Eclipse. It requires minimal setup to view and edit source code. COBOL source is displayed with syntax coloring, and the IDE will highlight incorrect syntax as you type. However, this mode has some limitations on configuring the way you work, using the debugger, and options for building your application. For example, in standalone mode, you can only build COBOL programs to int or gent compiled formats. Let's take a look at standalone mode in use. In Eclipse, I'll open a simple program directly from the IDE with File Open. You can see that the code is automatically color-coded, and the editor is aware of proper COBOL syntax. In standalone mode, a program is not automatically compiled when I save changes. I compile by right-clicking on the displayed source and choosing Compile. Once compiled, I can debug a program by right-clicking again on the source and choosing Debug as COBOL Application. I'm prompted to switch to the debug perspective that's better for debugging activities, and then I can debug the program. The recommended way to work in Visual COBOL for Eclipse is to use projects. This provides more control of how an application is built, including building to other executable types. Many more product features and configuration options are supported. One small example, with projects, debug breakpoints you've set in a program are retained between Eclipse sessions. With projects, you can also build code to native executables, shared libraries for your platform, and even Java class files. By default, local Eclipse projects are stored as a subdirectory within the workspace. Projects are a collection of resources, folders, and files, as well as settings related to working with these items. An Eclipse workspace can contain multiple projects. There are many types of projects available in Visual COBOL for Eclipse, related to different kinds of development work. In this video, I'll demonstrate working with a simple COBOL project, with files saved and executed locally on the Windows desktop. Visual COBOL also supports remote projects, which allow you to use the Eclipse interface on a Windows or Linux desktop, but the project and files are saved, compiled, and executed remotely on a supported Linux or Unix server. Working with remote projects involves the additional use of the Rocket Visual COBOL Development Hub product, which will be covered in another video in this series. Also, projects and the options and features they provide will be discussed in more depth in another video in this series, Working with Eclipse Projects in Visual COBOL. Staying with our simple introduction, I'll create a local native COBOL project by choosing File, New, COBOL project from the Eclipse menu. I can choose whether I want my COBOL programs to be built for execution in 32 or 64-bit mode. Finally, I'll give the project a name, Eclipse Intro, and click Finish. Now I'll create a simple COBOL program. First I'll click on the project I'm using, Eclipse Intro. Then I'll use the menu to select File, New, and then choose COBOL Program. I'll call the program Hello VC Eclipse.cbl and click Finish. There is a delay at this point because by default, each time a buildable file is added or changed in a project, Visual COBOL will rebuild the project, meaning that it will recompile the affected programs. In our new program, I'll define a COBOL data item to contain a message to be displayed. As you type in the editor, the line is automatically syntax checked. Notice that the field name is shown with a line through it. This is because this variable is not yet used anywhere in the program. There is also a warning symbol in the left margin, on the line where the value literal is entered. If I hover my mouse over the warning symbol, I'm informed that the literal is longer than the defined storage. I'll fix the length. Now I'll add a display statement to our simple COBOL program. As soon as I enter the variable name, the syntax checker removes the strike-through from the line up above where that variable was defined. Notice that if I make a mistake with a COBOL keyword, the editor recognizes and highlights it. Also, recognized keywords are shown in purple, while literals are shown in blue, and other names, such as data items, are shown in black. These colors are configurable. This feature will be covered in the video Eclipse Editor Basics in Visual COBOL. Now I'll save my change, for the moment ignoring my typing error. Once again, the program is automatically recompiled. Notice that the console view shows messages from the compile process and indicates the overall success or failure of the build. Finally, I'll fix my error and save again. Now the console shows a successful build. Let's experiment with running and debugging our program. Running a program is full-speed execution in the IDE and involves creating or selecting a run configuration suitable for the kind of program I'm running. An Eclipse feature named Run Configurations allows you to specify certain aspects of how the program will execute. Since this is a simple COBOL program running in the same environment as Eclipse, I can use a predefined run configuration. I'll right-click on my program and choose Run as COBOL Application. The program runs, and output is displayed in a separate window. In this simple demo, the program was saved and built on the same machine where Eclipse is running. Different options and setup are required for running a program on a remote system. Now, let's try running our program in the debugger. The debugger provides the ability to step through the program, interrogate and change values of variables during execution, and place breakpoints. Using the debugger also requires a debug configuration. Once again, we'll use a default debug configuration to debug our simple program. I've added a few lines to our program to help demonstrate the use of the debugger. Instead of right-clicking on the program this time, I can also access the options to execute a program from the Eclipse menu. I'll choose Run Debug as COBOL Application. Visual COBOL for Eclipse recognizes that a different perspective is best used for this type of task and offers me the option to switch to that perspective. I can step through the statements in my program by pressing F5 or by clicking on the Step Into button on the toolbar. While in the debugger, hovering the mouse over a data item shows information about the item's definition as well as its current value. Another way to see the value of variables on the current and previous lines is to look at the Variables view. The contents of a data item can also be changed in this view. I can set breakpoints on a line by double-clicking on the left margin. When I click the Resume button, the program proceeds to the breakpoint and stops. I can ask the debugger to advance a statement at a time through the program by clicking the Animate button on the toolbar. The execution proceeds until I click the Animate button again, or the end of the program is reached. I can switch to running full speed by clicking the Continue button, and execution proceeds to the end of the program. That completes this demonstration. This video has been a brief introduction to Rocket Visual COBOL for Eclipse. Please see the other videos in this series for further exploration of product features and options. Thanks for watching.